I will be doing quiz 4, and the problem states that Pee-wee must pass through 2 stop signs on his bike ride to school. There is a 0.2 probability that he needs to stop at the first sign, and a 0.6 probability that he needs to stop at the second sign, independently of what happens at the first. Let x equal the number of signs at which he must stop on a given day. In subproblem A, we need to write down the probability distribution of x. In order to find the probability distribution of x, we need to first make a tree diagram. Now, in the problem, it says there is a 0.2 probability that he needs to stop at the first sign. So, for the first part of the tree, 0.2, there's a 0.2 probability that he will stop. So that means 1 minus 0.2 equals a 0.8 probability that he doesn't stop at the first sign. Now, in the second part of the tree, in the problem it states that there's a 0.6 probability that he needs to stop at the second, and now the key word is independently of what happens at the first. So that means the second part is separate from the first time. So, and it says that there's a 0.6 probability. So that means 0.6. There's a 0.6 probability. 1 minus 0.6 is 0.4. So that is the probability that he doesn't stop at the second sign. So since we made our diagram, we can finally write out our distribution of x. So like I said, let x equal the number of signs at which he must stop. So x, you can label x as 0, 1, and 2, and so the probability of him stopping at 0 stopping at no signs is 0.8 times 0.4, which is equal to 0.32. The probability of him stopping at one sign is 0.8 times 0.6 plus 0.2 times 0.4, which equals 0.56. The probability of him stopping at two signs is 0.2 times 0.6, which equals 0.12. And if you add it all, it equals to 1. In B, it's asking what is the probability that Pee-wee needs to stop at least once on his way to work. We've already found the probability of the number of signs at which he must stop. So the probability of at least one stop is equal to 0.8 times 0.6 plus 0.2 times 0.4, which equals 0.56 or 56%.